SQL is an amazingly well-designed declarative language for getting data. You specify which data you want declaratively, you write the query, you execute it, and you get the data. And because SQL is so declarative, then the simple things are super simple. If you want to select everything from table, you just write a few words and you get back the data. If you want to select data from multiple tables, then you simply do join between the two tables or the multiple tables. You specify which field you want to join by, and then you execute the query. If you want to group by and order by, then this is also pretty simple because you just specify which columns you want to group by and which columns you want to order by. However, because it's so declarative, then when you need to get into nitty-gritty details such as, yes, I want an aggregation, but I don't want this aggregation to be on a whole group. I want to get the first item for a specific group. For example, if I have multiple branches of my company, then I want to get the topmost selling product, for example, for each branch. This involves in standard query a self-join. However, this is why we have the window functions. So just like you have the count, the average, and the sum functions, you also have a function named over, in which allows you to get the first item from a group. For example, the top selling product for a group. Let's say I have a log file, and in this log file we have errors, and we have extracted all the lines containing the errors with exceptions into another file and imported them into an SQL. And now we want to query this SQL of all the errors, of all the exceptions that we have for all the lines. Then the simple thing would be to do select star from errors table. This would simply return all the errors. And now let's say that for each error, for each such result, if we had 1000 errors, then we want for each line of the 1000 errors that SQL would return to us, to return how many times did we have an error of that category. So if the first line out of the 1000 lines that were returned is a null pointer exception, and null pointer exception has happened 20 times, then we want in this line to say first line, null pointer exception happened at 5 p.m. and in general the new column would be the number of this category, so 20 times null pointer exception has happened. How should we do this? Because if we use the standard group by, then it would not return the same amount of lines, so we need to self-join. But in order not to get complex with self-join, we could use the simple windowing function, which is the over function in SQL. So the way to write such a function is to use the over function. Where do we use it? In our example, we use it in the select because we want a new column to appear in the select and to tell for each line in the result how many times did this category appear. So we do select a star because we want all the columns, comma, count of exception type. So we did select star, comma, count, and in brackets exception type. And we assume that we have an exception type column already existing in our list of columns. And this is an aggregation because we used count of exception type. Now if we use the group by, then we would get a single row which would count the number of exception type that we have, and we would have to have each field in the select in the group by. Otherwise, the SQL would complain that we have fields which are not in the group by, and we did a count. So we did select star, comma, count of exception type, and we want to get all the 1000 results. So we use the over function. So it's select star, comma, count of exception type, comma, over, partition by, exception type from errors table. So let me repeat this. Select star, comma, count, brackets, exception type, comma, over, partition by, exception type, from errors table. So in this example, what we did is that for each row, we told each row, you are going to count the number of exception types that we have. Yes, you're going to count it, but we want still result a row per each standard result, as if we did a select star, and we did do a select star. We did a select star on the whole table, which means that we get back all the results, all the rows in the table, and in addition, an additional column with an aggregation. So this is very neat, and this is like the basic, and from this you can start playing around with partition by, you can add rank, for example, and then instead of getting all the rows, you would get the first row for each row, for each group. But once you understand that you can use the partition by and the over function in order to do windowing in your data, practically. Practically, what we're doing in general in SQL is that we run an SQL query where we select simply rows. But in this case, we wanted to have a summary per multiple rows. This means we wanted to have a summary for each exception type and still get all the rows. Okay? For example, let's say that we want to get the top basketball player for each country. Okay? So we want to display all the basketball players, and for each player for each country we want also to present the top basketball player. So in this case we don't only group by country, but we want also the top basketball player. Okay, so in addition to getting all the rows, we could say that we want to get the first and the top basketball player for each country. And it's not a simple group by, because if you do group by, then you need a function. The function in our case is not something like first or something else, which might be available for you, but usually the standard function are count and sum. But if you want to get the first one, then you either use a special function like lead, which takes the first one, but you need also the over and the partition by. This means that we want to go by country and then select the first player. Usually the way that we do this is to join the table with the same, to join the table with itself. But if we use the partition by and the windowing function and the over, then for each row, then the window function is computing across all the rows that fall into the same partition as the current row. So window functions are permitted only in the select list and also in the order by clause of the query. They are forbidden elsewhere, such as in the group by, or in the having, or in the where clause. And this is because they logically execute after processing all of these clauses. So in order to use a window function in an SQL query, then we need to create this window function. To create this window function, we use the over clause. This is the function that we use, just like you use count, just like you use sum in the select clause of an SQL. You can also use over, which is another function. Count, sum, and over, another function for you. And now that we know that we can partition the rows that we get back by, let's say in our case it was the exception type, then all we need to do is to combine it into a simple standard SQL query, which we used, select star, and then we also added the additional column which counts all the exceptions that we had of this type. And this is a query that combines a windowing function It's a standard SQL query that contains some kind of an aggregation function. In our case, the aggregation function was simply an aggregation of counting the number of exceptions in a group. And we did this with a simple select. Select star or select any column, comma, count of the column that we want to get a grouping of. And then we need to specify as if it was a group by, but it's coming inside the select, over partition by and which group, in our case exception type. So over partition by except type from a rows table. So we had a standard SQL select statement. One of the fields in our select statement was a windowing function. It was over partition by X, something, some column. One of the fields in our case had an aggregation. It need not be the same field that is in the partition by. The partition by is partitioning to windows, and then you do some kind of an aggregation, and it could be on another column. And one of the fields that we used in the select did not have any aggregation. Okay, so not all the fields in the select need to have any aggregation. Some fields have aggregation, some fields did not have aggregation. And for the specific fields that do have aggregation, we specify the over and the partition by. So if you look at your select statement, you could see multiple fields. Some of them have aggregation such as count. And then usually what you would do is with group by, you would group for this count, but then you would need to have all the fields in the group by. But in the case of a windowing function, you say I want field A, B, C and the count of D, and I want the count of D to be grouped by with the over keyword, with the over function, partitioned by something, some column. And in this case, we would get back all the rows that we would get with a standard SQL query, including a windowing function over one of the fields. And if, in the beginning, we said that we wanted to get the topmost player, or for each group, some kind of a type that appears the most. We want to get the first one. For this case, we use the rank function. So the rank function is a function that we apply over the partition that we say. So what it would do basically is that it would assign a number of the order of rows for each window. So for each window that you get, if you did over partition by and the exception type field, then you would have multiple exception type. But for each exception type, you would have multiple rows. So using the rank function, we could have one row 1, 2, 3, 4 for one exception type. And then if you continue looking at the result, you would see again 1, 2, 3, 4, 5, 6 for the next exception type. And in this case, we get a ranking of all the results within each window. Once we get this ranking, we could then limit the result to have only rank equals to 1. And with this, we could get the first result within each grouping of windows. So we could ask for all the rows, give me all the rows with the select, okay? Then partition by one of the columns, which would return all the rows, but would like set windows on and grouping on all the rows that you get back. And with the rank function, we can assign a number, a sequential number for each of the results, but it would go back to 1 within each group. So if you want to get the first one, then you would say where the rank is 1, the first rank. So this would give you the first result. To sum up, SQL is a great declarative language for fetching data. However, some operations could be complex, such as give me the first row within each group, which would involve doing a self-joins. But in order to avoid the self-joins or utilize a very nice function of windowing, splitting the result data into windowing, we use the over function. The over function receives an argument which is partitioned by a specific column. So he said, yes, I do want you to give me back all the results, but I want you to group them within themselves. I want you to create windows. The window could be for each minute, and then I want to get only the first one within each minute. Or I want to do an aggregation, and in this aggregation, I want to see the result within each row. So this is very strong. Once you start using the window functions, which are simple, okay, the syntax might be a little bit perplexing, but I promise you that once you start using them, you will simply not stop using them because they are so great. They help you write concise and very simple SQL queries that otherwise would be very complex. So this really helps us still continue using SQL in a very declarative way, while also continuing to be simple and avoiding the additional complexity that comes out of using such a highly declarative language. So I hope you enjoy this. Stay safe in the corona, and we see you next time.